Okay, in this video, we're going to mainly focus here on just inverse functions. And then from there, we'll go on to more about logarithmic functions and their basic properties. But now we're mainly focused on inverse functions. So first of all, in order for a function to have an inverse, it must pass this test right here. It must be a one-to-one function and must pass the horizontal line test. In a basic function that seems simple that would not have an inverse function is this, because the y equals x squared does not pass the horizontal line test and therefore is not one-to-one, therefore has no inverse. Okay, so looking at how an inverse is written, so you would say f, this should be a negative, can't really see it, but f to the negative 1 of x, that's the inverse function of x, or f inverse of x. And it's the result of composing one function and its inverse, so putting its inverse inside of it, and then your output is x. Okay, so two steps, and these steps can be, they don't have to be 1, 2, this can be 2, that can be 1, doesn't matter. Okay, but basic idea is you're switching x and y, x for y. So since you're switching x for y, basically what you're doing is you're relating one function to the other function over the y equals x. So you're reflecting over the y equals, x axis. That's what you're doing, and finding its inverse. So you're reflecting over the y equals x axis. Okay, so if we take a look at this, what we want to do is go ahead and find the inverse and verify that these two statements are in fact true. So first of all, the inverse is if we switch the x and the y, so it's going to be x is equal to y to the third. And then we solve for y, so bring this 1 over, so that'd be x plus 1. And this is y to the third, so take the cubed root. So then this is your inverse. Let me highlight that so we can clearly see that. That's the inverse right there. So this first statement right here, f of f inverse of x, that says put the inverse inside the original function. Okay, so if I put it inside here for x, you would have then the cubed root of the quantity x plus 1 to the third, all that minus 1, and then you can see the cubed root and the cube, the third power, is going to cancel, so you'd have x plus 1, then you would have that minus 1, those 1's cancel, so you have x. So the first one shows that it's equal to x. Let's go ahead and try the second one. So now it's f inverse of f of x. So you're plugging the inverse into, you're plugging the original function into the inverse. So it would be the cubed root. And then for x, I'm going to put x to the third minus 1. And then we simplify this. X to the third minus 1 quantity, that negative 1 and positive 1 can cancel. So you'd have the cubed root of x to the third, which is just x. So we know, in fact, that they are inverses of each other by testing, by plugging one inside the other, then the other inside the first one. And your output each time should be x, because they just get rid of each other. Okay, so that's just a quick review for inverse functions, how to find them, and how to check to make sure that they're true. Again, graphically, just use the horizontal line test, meaning it shows that they're one-to-one or not. So if it's not one-to-one, it fails the horizontal line test. If it's an even function, it's going to fail the horizontal line test most likely. and not be one-to-one. Therefore, it's not going to have an inverse. Remember, its inverse is just a reflection over the y equals x axis. So it's going to have to be most likely an odd function.